Hello YouTube, welcome back to my channel. So in today's video we are going to go ahead and learn how to build a web application, web 3.0 applications, basically blockchain applications using Python. So the blockchain space has been mostly dominated by JavaScript with libraries like Truffle and so on, Ganache and so on. So Python is also coming up in this space, and we are building. There are a lot of Python frameworks that you can use, the most popular one being Brownie, and Brownie is used by a lot of some companies in blockchain, but for most part of which the blockchain sector is dominated by JavaScript. So Python is also picking up and growing, and hopefully Python will overtake JavaScript in the near future. So as Python is a channel that deals mostly in Python, in today's video we are going to learn how to build blockchains using Python Brownie library. So this is what we're going to build. We're going to build a simple storage application that can be used to store student details, so the student name, the age, and then this the other stuff like that. So you can also use this to build a simple to-do application using Python, okay, using a blockchain. You can build a simple to-do app in blockchain. So that's what we're simply going to do. I have all the steps written, and I'm going to go and explain to you every of the steps. The first thing you're going to be using a language called Solidity, and this is a language that powers the creation of smart contracts. So you can just go into the Solidity and you can search solidity lang.org, and then you can read about the documentation. So you can read about the documentation just to get yourself familiar with Solidity, and then if you also don't know Solidity, it's okay, we'll go over all of that. So Solidity mostly it's actually very similar to maybe JavaScript, I'll say, but yeah, it also has these accessors like Java and other stuff like that, but it's fairly very simple. If you know programming as well in Python, you definitely catch up with Solidity. So having a basic knowledge of Solidity is important, but if you don't worry, we'll go over everything step by step in this tutorial. So once we have that done, great, we can go ahead and actually begin. So I'm going to leave a link in the description where you can find this GitHub repository, and this is a repository for our project, and it has all the steps to follow on how to do the project. Okay, so I'm going to explain to you everything you need to install. We also need to get something like Metamask and all those other crypto wallets and stuff like that, and I'm going to explain to you all of this. Okay, so the first thing we need to do is actually go ahead and create a folder. So I have a folder here called this folder here. So let me just make my desktop a bit bigger, and then let me try to make this a bit larger. So I'm just going to clear the terminal, so make this a bit larger. Okay, so I hope you guys can see on that. So once you're done, what you need to do, the first thing you need to do is actually install Brownie. So Brownie is a library that is used to build smart blockchain applications and other web 3.0 applications using Python, right? There's also Python 3 web 3.py library that you can also use, but Brownie is just so smart. They have done everything, so you don't have to do a lot of the scratch work. They have put everything together that makes it to develop blockchain and Python very simple to follow. So if you're new to my channel, please kindly consider subscribing and like this video to so that you can stay updated whenever I post new videos on Python and blockchain development. So the first thing we need to do is to follow these instructions and have Brownie installed. So I already have Brownie installed on my PC, so I'm not going to go ahead and actually do this, but you can follow these instructions and install Brownie. So these instructions you can just read off your documentation and see what you need to do. So I have kept all the important instructions on this page. So the first thing you need to do is to run this command, and this is going to go ahead and install Brownie, and then you need to run this this command, and this is going to go ahead and also install some other dependencies that Brownie is, and then you need to create and install the Ethereum Brownie, which is just an Ethereum load about the Ethereum blockchain, right? So it has a link to Brownie, and then you have to. So once we have that done, before we go to the installation process, I forgot one important thing to mention. So we don't need to create a Python. You don't need to create a Python virtual environment and then run all these commands. You can just use pip. Since using pipx, this will be installed in a global Python environment, and whenever you open up your terminal, it will automatically load it using pipx. So you don't have to create a virtual environment to get this installed. So just open your terminal and then install this without a virtual environment. So once we are done that, we went to the process of running all these commands. Let's go ahead and begin a new project. So I'm in my directory here in my folder. I've created a simple folder. So let me just do an ls. So you can see I have a simple folder here called simple storage. Okay, and that's what we're going to go use for our project. So I'm going to change directory into my simple storage. So this is going to be our project directory. So in here you can see this project is currently empty. Okay, so now we can go ahead and create a new project. So I have to write Brownie in it, and that's done. So I'm just going to copy this and then go into my terminal and then just paste it there, or you can just say Brownie init, just like this. So once I have that, I can simply press enter. This is going to go ahead and create for us a Brownie project, and you can see that the Brownie project has been created successfully. So I can do an ls. Now you can see I have all these folders inside of my project. Okay, so if I do an la to also show the hidden files, I also have a git ignore and all that git attributes and stuff like that. So once we have all this done, I'm going to clear the terminal, and once I have this cleared, I'm going to open up this in my favorite text editor, which is VS Code. Feel free to follow along using any text editor that you're comfortable using. So you can see that my VS Code has been opened up. So now that my VS Code has been opened up, I can just go ahead and close all of this. So let's go back to my repository, and then I'm going to explain to you the file structure of the project. So let's go and analyze the file structure and what each of these does. So there's the build folder. This keeps tracks of the deployed contracts. Okay, so if I build a contract and deploy it, it's going to be kept inside of the build folder, and inside of the build folder, the contracts folder and the various interfaces, okay, are all going to be kept in the build folder. So let's go into the build folder and let's see what's inside. So if I just open this up, you can see we have contracts, deployments, and then interface. These are just subfolders, right? So if I go back here, you can see that the contracts it contains the following folders, right? 3 folders: the contracts folder, the interface folder, and then the deployment folder. Okay, so this keeps track of, if you have if you deploy a contract, it will be kept in the deployment folder. All your contracts will be kept inside of the contracts folder, and then the interface will be kept inside of the interface folder. Okay, so these are just basically it. Let's not go into depth about the more of the low level stuff for now. So also one thing, also we have the contracts folder that is outside of the build folder. Okay, so we also have this contracts folder, not this one, but the one that is outside the build folder. This way we're going to write all our contracts. We are going to write all our smart contracts using Solidity. So if you want to write a smart contract, it's going to be kept inside of this contracts folder. And then interfaces, where we're going to keep our interfaces. So interfaces is just it contains different information that you can get. Like to work with the blockchain, you need 2 things. You need the blockchain address, to work with the smart contracts, you need 2 main things: the smart contract address and the ABI. So ABI stands for application binary interface, and this is what you need to connect to the smart contract. These 2 things: the address and then the interface, the address and then the ABI of the contract. So the interface folder keeps track of all those information for us, so you don't have to worry about getting all that information, unlike in Python, web3.py, where you have to work to get the ABI and stuff like that. In Brownie, it takes care of all that for you. So this folder, this way we keep our different files that we are going to use to test our program, right? It's always good practice to always make sure that you test your application before pushing them out, especially if you're working with smart contracts, right? Whenever you deploy them to an actual live blockchain, if you do forget to make if in case there are any errors, you can't really update it, right? Because these are permanent informations. So make sure that you have to test your applications well and before they go into the blockchain. Also, because blockchains sometimes they do it with financial applications, so any mistake can be very, very costly for you. So you have to test your applications and your contracts before deploying them, and that's where you're going to instead of the test folder, that's where you're going to write our Python files to run our Python tests. And Solidity, in Brownie, you're going to be using PyTest for that. And if you're new to PyTest, I have a whole tutorial on my channel about PyTest and introduction to PyTest. It's just a Python library that is used to write tests for applications. So go back and you can go and check that video in case you're interested in PyTest. Okay, so now that we have gone over explaining all these folders and what they do, great. So let's move on to see what's the next step. The next step, we're going to go ahead and actually set the testnet development. So testnet development is whenever you're building your application, right? Sometimes you want to test your application locally, or you can also test your application on testnet, right? It is just a replica of an actual blockchain, but it's not owned by you, right? It's owned by different companies, and they allow you to use their resources for testing. So we can use testnets to test our application. So they're just mocks of an actual blockchain, but they're used for testing. They're not an actual blockchain, but you can use it for testing, and they're not running on your local machine, but they're running on the web. Okay, so you can test them on testnets before deploying them to an actual blockchain. Okay, so to work with the testnet, we need 2 main things. The first thing we need is an Infura project ID. So to open an Infura project ID, the first thing you need to do is actually get the Infura account. So let me just go open you can click on this link right here. So if you click on this link, it brings you to Infura Ethereum ico.io. So you can, I'm going to leave all the link to that repository in this repository so that you guys can find access to it. So you can click on that link and it's going to bring you to this web page and give you the instructions on how to get a web ID, a project ID, Web3 project ID. So the first thing you need to do is to register. I've already gone ahead and registered. After registering, you can just click on one of these and register. After registering, you need to verify your email account. After that, you can create an Infura project. You can give it any name you want, just like they call it test here. So after doing that, you get something called a project key, a project ID right here. So project ID, this is what we are interested in. So this is what we need to access the web. Okay, so that's a project ID, and that's how you can go about creating the project ID, a Web3 project ID. So once you have your Web3 Infura project ID, great. So one thing you also need a private key, and if to get a private key, you need to install Metamask. And to install Metamask, I'm not going to go ahead and show you how to install Metamask in this tutorial, but what you can do, I already have Metamask installed, as you can see. So you just go ahead, Metamask install, or you can just go metamask.io/download. So you can just go there, and then I'm using Brave browser. So if you're using Chrome, just click on Chrome. If you're using Brave, you can click on Brave. If you're using Firefox, and then if you're using Microsoft Edge, then you can click on that. So I'm using Brave. I'm just gonna click on Brave and then click on that. I already have Metamask already installed, so you can see it's already installed here. So I'm not going to show the process of how to go ahead and install Metamask. I have this link right here. This link takes you to the official page. So let me just click on this. This takes you to the link where you can download the Metamask. Okay, so let me just go back here. And once you have that download and properly set up, what you need to do is also you need to have a Metamask key, right, to get the private key. You need to watch this video. So this is from the Chainlink. Chainlink is one of the leaders in blockchain development in the Python environment. So one of the things you can do is actually watch their video. They explain it well on how to create a Metamask and get the private ID. So I'm not going to explain that in this video because these guys explain it really well, and it's important that you watch this video and set up your Metamask because it deals with your financial details. So it's better that you watch it from these guys who are real professionals. I'm not professional. I'm not really a professional blockchain developer. So watch this tutorial and then you can actually see it from the professionals and how to set up your Metamask. So go ahead and click this link and you watch the YouTube tutorial on how to set up Metamask. So I assume that you already have Metamask already installed, and then you also have your Infura Web3 project ID along with your private key, which is going to come from your Metamask. Okay, your Metamask file. Okay, so once I have that, let me just go ahead and close all of this for now. Since you are done using Metamask, so let me just close this. So great. So once you have that done, what you need to do right now is you need to go ahead and watch that video and set up the private key for your project. Also get the Infura web ID, and I give you all the instructions on how to do that by clicking on these three links. You can watch the videos and read the documentation on how to do all that. Once you have that set up, you can also run your blockchain locally on your own computer. And to do this on your own computer, you need to install the following. So you need to use npm. So if you are like, okay, I hate JavaScript, but okay, just to set up, since JavaScript is leading the blockchain hemisphere, so what you're going to be using, we need to use Ganache, and Ganache, you can get Ganache by using npm. So just copy this command. I already have Ganache installed, so just copy this command and paste it in your terminal, and then install Ganache-cli. So CLI stands for command line interface. Okay, so you need to install Ganache-cli, or you can also install the Ganache UI if you want, but you need to have the Ganache-cli installed, must, because Brownie uses the Ganache-cli. So if you don't have it, then it won't work. So make sure that you have the Ganache-cli installed. Okay, so make sure that you have npm also installed before running this command, or else you run into an error. So once we've done that, we are all set to go. And now we can go ahead and create a simple project. And to create this project is very, very simple. So let me just go ahead and go into my my VS Code here. So I assume you guys have everything already set up. So I'm going to go into my VS Code, into my project right here. And what I'm simply going to do in here, I'm going to go into the contracts, and inside of the contracts, I'm going to create a simple file which is going to be called simple storage .py. Great. So create a folder like that. Is a file called simple storage .py. Okay, I made a mistake. Now you might be thinking, okay, we're building this in Python, so we need to actually write this in Python, right? But no, we don't need to do this. Is not supposed to be a Python file, because all our smart contracts, as I said earlier on, they're going to be using a language called Solidity, and Solidity, the file extension for Solidity is .sol. So we need to actually write Solidity and not Python code. Okay, so let's go back in here, and then I'm going to rename this. So I'm going to rename this and make sure that I change the extension to Sol, which stands for Solidity, because we need to have the Solidity installed. And if you don't have the library, the VS Code library for Solidity, you just go to extension and then search for Solidity. And also you can install that package for Solidity, which can help you in when you're writing Solidity program. So you can see I have this one already installed on my machine. Okay, so make sure that you have that installed. So once we have that there, let's go inside of this file, and what we're going to do, we're going to write our Solidity application in here. So the first thing you need to do, let me just go back to offshore documentation. So let me just bring this back. I'm going to go to offshore documentation, and I need to get the SPDS license. So I'm going to license identifier. So I'm going to copy this and just paste it here. This is something that you need to have for your program to work properly. Okay, so once I have this, I'm going to say pragma. So I'm going to specify the Solidity version that I want to use. So pragma, I'm going to say Solidity, and then let me get that right, Solidity, and then this is going to be we're going to use version. You can also copy this. You can also copy this from the official documentation. So if you go to the official docs, you can also get this from here. But this is just specifying the version of Solidity that you want to use. So let me just paste that right there. So once we have that done, I'm simply going to go ahead and create my smart contract. And to create a smart contract in Solidity, we need to use the contract keyword. So I'm going to say contract, and I'm going to say simple storage. Okay, I'm going to give the name of the file. So this is going to be our smart contract in here. So great. So once we have that set up, what I simply want to do is to create an application whereby we can store a student's name, the age of the student, and then the faculty in which the student studies. Maybe he studies computer science, or so it's going to be in the computing and engineering faculty. Maybe studies maybe engineering, so it will be in the engineering faculty, and so on like that. So just going to create something simple. You can turn this into a to-do list application if you want, but for me, I'm just going to keep it as simple as this. So the first thing you need to do, I'm going to create a struct here. So I'm going to say struct. I'm not going to go into depth explaining Solidity, so I'm going to just create a struct here, and this struct is just going to have the following. So if you're coming from C++ and other languages, you probably come familiar with structs and stuff like that. So I'm also going to the name is going to be a string, right? A string type, and then the age is going to be, I'm going to use uint 256, and I'm going to call this age. And also one thing you can notice, I'm ending every line with a semicolon, because in Solidity every line must end with a semicolon. Okay, so this faculty is going to also be a string again, so I'm going to say faculty, just like that, and end that with a semicolon. So once I have that done, I have created my struct. I can use now this to create different things. So I'm going to create a list in which you're going to store each of our students, right? So I'm going to create a struct. I'm going to call it a student. This is going to be data type, and then data type or type string is going to be public, and then I'm going to say student, just like that, students. Okay, I'm going to call it student because we're going to store all our students instead of this struct list. Okay, or struct array. Okay, so you can see this is a data type right here, and then this is public access modifier, and then the student. So the public will enable us to get access to this student variable, which is going to be this struct or list of struct or array of structs, without actually having to write a function like a getter and a setter to do it. So public will enable us to get access to it without having to write a getter and a setter like in Java or other programming languages, right? So once I have that done, I can simply go ahead and do a function, and I'm going to say create student. So in here, I'm going to take in the name of the student, the age, and then the faculty, because if you want to create a student, you provide us all these details, right? So you can think of this as a set method. So I'm going to say string, and I'm going to say memory. This is going to be memory, and the memory I'm going to simply say it's going to be underscore name. So saying that memory, what it simply does is that in Solidity you can store data in two formats, right? We can store it on the memory, which is just whenever the program is running, right? We are able to get access and use that application. Whenever the program is closed, then this will get deleted, because this means that it's not going to be permanently stored on the blockchain. It's only going to be stored whenever the program is running. Once we close the program, it will disappear, right? It will be erased from the memory. So memory will enable us to store the data in memory when the when the program is running. Okay, when the program stops running, then that won't be in the memory anymore. Okay, and there's another way you can store it permanently on the blockchain, but you're not going to cover this in this tutorial. Okay, so once I have that, I'm going to also go get access to the age. So an int, I'm going to use 256, and this is going to be, I'm going to use _h, and then I'm going to get another string memory, and this is going to be _faculty, just like that. So once I have this done, I can simply go ahead and say, so I can simply say, let me just simply go ahead and close this off, and then I'm going to go ahead and simply say the following. So I'm going to make this function a public function, because in Solidity there are different access modifiers. There is internal, there is external, there is public, and all of that. So you can read more about this on the official documentation right here. So if I try to so you can see, I just opened up this documentation, and you can see this we have the different visibility functions, visibility specifiers they are called. So you can read more about all of this, and you can see also have different other forms here. So you can also see we have memory and other stuff like that. So yeah, that's all. I'm not going to go into depth about this, but you can go ahead and spend some time reading this. So okay, so once I have that done, I'm going to, in here I need to forget one thing. I need to say that this is a public function, because we want to be able to access this function outside of this contract, right? Not only within the contract. So I'm going to go ahead and say student. Now that we're going to get the student, we're going to create a struct. So I'm going to call this struct is going to be stored in my memory, which is going to be temporary, and I'm going to call this new _student. And this is going to be the following. So going to be the struct. I'm going to get the student struct, and in here I need to pass in this an object, so which is a dictionary in Python, right? So I'm going to say name, and name is going to be _name, and then I'm going to say the age, and the age is going to be _age, age, and then I'm going to say that the faculty, and the faculty is going to be _faculty, just like that. So once I have all that done, let me not forget to end that with a semicolon. So great, this is going to create a struct containing the student, right? So once we have that specified and that's done, what I can simply go ahead and do, I can say students students.push. I'm going to add this to the students, and I'm going to say new _student, and then let me not forget a semicolon right here. So we're going to create a struct of object. After creating the struct, you're going to go ahead and store the struct inside of this struct list right here, which is called students right here. So I'm going to get this and then .push, and I'm going to push in that new student. And once we have that specified, that's going to help us to create a function, student. So if I call this function, it's going to go ahead and create the student for us. So once I also want to have another function that is going to return to us the student's information. So I'm going to go ahead and create a function here. Function, I'm going to call this is going to be students info. Okay, there's an s there, and this is going to be a public. The function visible is going to be public, and then the view is going to be view, and then returns what it returns. And it's going to return the struct of type list type, and then it's going to be from the memory. Okay, temporarily going to be stored in the memory. So once that I have this written, now let me just go ahead and explain to each part of what I have said. So the public is going to make the function visible to be public, means that we can access this function outside of the contract. The view means you're only going to be viewing the content inside of the contract, and not actually be able to modify it, right? So it's just like a getter, you can think of it like that. And since you're going to view, you're going to be returning something to be able to see it, right? So you're going to be returning the student this struct list, and then it's going to be from the memory. So what I want to go ahead and do, and just simply return and return students, just like that, and don't forget the semicolon. So it's going to return to us all the students that have been stored inside of this struct here. Okay, so once I have that, I also want to create a function that will return to me information about only one specific student. So I'm going to say function, and this function is going to be student info, and this is going to return to us the information of only one specific student. So how do we get one specific student? Now the first thing we need to have an ID to identify that specific student, right? So I'm going to have a uint, unsigned int of 256, and I'm going to there's going to be students student. I'm going to say student underscore index, and then I'm going to say this function is going to be of type public. It's going to be a view, okay, because we're just going to view the content of the blockchain. You're going to modify it of this contract. So returns the students memo. Okay, because it's going to be returning a struct which is going to be similar to this struct right here, which is called students. Okay, so once we have that done, we can simply go ahead and say that this is, we can go ahead and open and close that. So I see we have an error right here, and this is going to be capital student, so make sure that is capital S. So we actually call it student and not student, okay, the name of this struct right here. So once we have that done, I'm simply going to go ahead and return students. This is going to be students, so it's going to be a small letter S, so students, and then I'm going to get the student with the ID, the index that was provided when the function was called. So whenever this function is called, it's going to be a passing index, and we're going to get the student with that specific index. So let me just go ahead and close this right here, and this line off with a semicolon. So that's all we need for our contracts. So a person can be able to add a student by calling the create student function, providing the name of the student, the age, and then the faculty, and this will be added to we'll create a struct object from this struct, and then to be added to this struct array right here. And then from that we can be able to access all the students just by calling this function get students info that returns to us this whole array. And then also we can also get information of one specific student, so you call this function student info, provide a student index, and then to provide you the student detail, okay, return to the student details. So that's all we need. So once I have this done, that's all we need for our contract. So let me just open back my side panel here. So once we have that, let's go back and see what we need to do. So let me just go back to my blockchain and my GitHub page, and let's see what we need to do. So the first thing we need to do now, we need to deploy this, right? So you can either choose to deploy this locally on Ganache, or you can deploy it on a testnet, and I showed you how to set up a testnet and how to get Metamask and all of this, okay? The links are here. You can just open up those links and watch those videos and read those articles. So the first thing we need to do is actually, I'm going to go to run this command so you can see all kind of networks we have. So I'm just going to open this, and I'm going to say Brownie, I'm going to say run, sorry, not run, this is going to be networks, and then list. So this is going to return to us all the networks that are available by on our machine. So if you have Ganache-cli installed, then Brownie automatically have all these networks set up for you. So you can see on development you have the Ganache being the first one, and then you have all these other ones that follow it. Okay, you also have all these other networks in case you want to use like so you can see we have all these development networks that have been set. We have Ganache, we have Hard Hat, and all these other ones. So in this tutorial we'll actually be using our development one, which is by Ganache-cli, because we installed Ganache, right? Ganache-cli using in npm. And if you know that command, the command is right here to install Ganache-cli. So once you install that, you have this command right here. You can see we have all these other nets that we can use. So for Ethereum we have mainnet, Rinkeby, and other ones. But in this tutorial we're going to focus on using Rinkeby on Ethereum network. So we're going to first go ahead and let's see what we need to do first. Let me just go back in here and see what we need to do. So this is going to return to you a list of all the networks, and the network that you're going to be interested in for now, you're just going to deploy it on our local Ganache network. And to deploy it, it's very simple. And let me just clear this. So if you don't know the commands, the different arguments you can use, you can say Brownie and then simply run this command. Just by running this command, you can see all of these commands that you can use. So you can use Ganache run, init to create a project, bake is to clone template, because mostly if you're working with blockchains, is sometimes you not be writing code from scratch. You'll be copying templates and then modifying those templates. You can also compile your stuff and other stuff. So let's go ahead and actually compile this. Let's compile our code. So let's say Brownie compile, and then run that. So this is going to compile our code, and in case there is any error, it will tell us. Now you can see that it has been compiled successfully. So now if you go into let me go into VS Code, and I go into my builds, and I can see contracts. You can see you have this right here, and this is what you get after it has been compiled. If you go to deploy, right now deploy is empty. You don't have any interface because all the compiled contracts will be stored in build/contracts, and you can see the compiled version of that contract here. So great. So once you have our contract compiled, you can go ahead and actually deploy that. So you can just say if you go back to this terminal right here, you can see we have the run command right here. So this is used to run scripts. So we need to run our scripts, right? And I told you in here, this is where we store our different scripts to automate stuff. So let's go ahead and actually run a script for this. So let me just minimize all of this. So I'm going to go into our scripts folder, and you can just write deploy the scripts file. And this is what you're going to be using to deploy our application. So just go to the scripts folder here, and then create a file called a Python file in this case, and then it's going to be called deploy.py here. So instead of deploy.py, that's where we're going to run our cases to deploy for us our application. So to deploy this application, we can use two ways. You can either use the testnet, which is I have showed you, or which are these ones right here, the testnets. In this case, you're going to focus on Ethereum testnets. We're going to be using specifically Rinkeby. Okay. And yeah, that's what we need. So for now we need to go ahead and actually run that. So let me just go ahead and edit this file. So I'm going to say from Brownie import. The first we need to import in here is our simple contract. So Brownie automatically knows where to get this simple contract. So there's going to say simple storage, and Brownie automatically know where to find this simple storage. So let's go ahead and actually run. You must have a main function inside of this thing, because the main function is what is going to be run whenever you try to deploy your application. Whenever you try to run a script, the main function will start to be run. So let's just print in here, print hello world. So let me just go ahead and save this, and then let me go into my terminal and then clear this, and I'm going to say Brownie run. So let me just run, and then we want to run inside of the scripts folder /deploy.py. So run this, and this is going to run the main the main function, and this is simply going to print it's going to simply print a hello world, right? So you can see it's deploying it to Ganache-cli, and you can see we have also gas limit, and also have gas fees and mnemonics and other stuff like that. These are all blockchain concepts. I didn't go over covering these blockchain concepts. I'm just showing you how to build a simple blockchain application using Python. So you can see that now we get back a hello world, right? So this function is what to be run. So now let's go ahead and write another function. This is going to deploy our context. I'm going to call it deploy, and I'm going to run this function right here. So the first we need to deploy an application. The first thing we need to do is actually get an account. Okay, so I'm going to say first go ahead and actually let's try to deploy this. I'm going to say simple underscore storage, and this is going to be the following. It's going to be the simple simple storage that we just imported, which is just our smart contract. So if you go in here, simple storage, you can see we have simple storage right here, this simple storage. So that's what we're trying to get access to here by importing it from Ganache. By importing it from Brownie. Brownie automatically know where to find this. Brownie is really smart. So you can just do .deploy, and just delete this .deploy. And instead of this deploy function, you need to pass in a dictionary. So the first thing we need to pass into this dictionary is from. So from where is this contract coming from? So we need to specify our account here. So you can just go to account, and then you can say you can also import account from Brownie. So you can just say account, just like that. So accounts. So you can just say here accounts, and then get the very first account, and the very first account is the account right here. So if you say account, is going to development account, and you want to get the very first one, which is Ganache right here, Ganache-cli. So I'm going to get the Ganache one. So in here I'm just going to go ahead and specify my account to be the Ganache account. Okay. So once I have that, I can just simply print to let the person know. So I can say F, and I'm going to use an F string here, deployed successfully at, and then I'm going to go ahead and specify the address on which this was deployed. So I'm going to say simple storage.address. It's going to return to me the address on which this contract was deployed. So deploy successfully. So I think I got that right. Yeah, wrong. So this. So deploy successfully at, and then the address at which you deploy the contract. Okay, so great. So now we have that. You can simply go ahead and copy this and simply paste it in here. Instead of printing hello world, you're going to call the deploy function, which is going to go ahead and deploy this. So this, whenever you run the script, this is going to be called, and it's going to call this function, and it's going to come up here and execute all of this. So once we have that, this is going to deploy our contract very simply. So let me just go ahead, clear the terminal, and then I'm going to write Brownie run, and I'm going to run scripts /deploy.py. So go ahead and run that, and this is going to go ahead and actually deploy our script for us on our local blockchain running on Ganache-cli. So you can see that the contract has been deployed at this specific address. Okay, so the contract has been deployed on this specific address. So great. So our contract has been deployed on our local Ganache. Okay, so once that we have our contract deployed, let me show you how to also deploy this contract on another testnet. In this case, you're going to be using Rinkeby. So let me just go and show you how to deploy this on a testnet. So to deploy this on a testnet, you're going to go ahead and import another thing called networks, and I'm also going to import something called config. So let me just explain to you. So network will enable us to have access to all the networks, and then config will enable us to have access to some configuration that we can set. So let's go ahead and actually set our configs. So let me just go in here. I'm going to add a new file, and a new file is going to be brownie-config config.yaml, going to be a YAML file, and also going to want to add another one, and this is going to be it's going to be a .env, so .env, so it's going to be .env file. So .env file, that's we're going to go ahead and keep our secret keys. Okay, so let me just go back in here and let me explain to you this part right here. So we're able to get our Web3 Infura project ID, and also we were able to get our private key from our Metamask. Okay, so this is how you can go ahead and put this inside of you can also copy this and paste it in your terminal. Just copy this and paste it in your terminal here, but this will be your actual project ID that you get from the website, right, the Infura website. So if you get the project ID, just paste it there and run it, right? But if you do it this way, it's going to add an environment variable that is only going to be temporary. It means that every time you want to every time you open your terminal, you have to export it and stuff like that before you can run your project. So this is very inefficient and time consuming. So the one way to do it is actually adding this information to your env file. So I'm just going to copy this and I'm going to go into my env file and paste it right there. So let me just put it properly. So in here, that's we're going to paste our secret keys and other information. So I can just go and get my secret key and other information, and I'm simply going to paste it in here. So I went ahead and copied and pasted my private key and other project ID inside of my env file, but now I can't open my env file because it contains my personal details. Okay, so make sure that you just paste it in here, and you can you can follow this format right here. Okay, so once I have that, now I need to get access to this. Okay, so I'm going to simply, the first thing I need to do, I need to tell Brownie that I want to get this information from a .env file, and then I also want to get which wallet I'm using, which is going to be my private key, right, which is going to be from Metamask. So I'm just going to copy this. You need to pass in this 3 lines to get this fixed. So I'm just going to go into Brownie and simply paste this here, and then fix that indentation. So fix that indentation. So that's all I need. So what I simply told Brownie here is you're going to be using env file, and then you're going to, in the env file, we have a private key, which is this part right here, the private key from our Metamask. And then under wallet you have from key, and the key is going to be this private key right here. So you need to copy this config files. Okay, this actually got the spelling wrong, so I'm going to rename this to be config. So sorry for that if you guys made that error. So it's actually brownie config.yaml file. Okay, so great. I'm just going to close all of this. Once I have this done, so to deploy it on a testnet, what I need to do, I need to get the information. So I'm going to have a function called def get underscore account. So instead of get account, I'm going to have a conditional statement saying if network dot show underscore active is going to show us the active network. So this is a function. If the network is going to be a development network, if a development network, what you simply want to go ahead and do is simply return the first network, right, because it's development and we're going to be working with Ganache. So if I go in my terminal and run brownie networks list, just like that, and it's going to show me the list of all the networks. So I'm looking for the one which has the development network, which is this Ganache-cli that we have. Okay, so if the network if the active network is the one of the Ganache-cli, what I'm simply going to do, I'm going to return accounts, and I'm going to return the very first index, which is this one right. Let me bring back my terminal. This one right here, which is a Ganache-cli network. Okay, if that's not the case, what I simply want to go ahead and do, I'm going to add an else statement. So I'm going to say else. I'm going to say return. I'm going to simply return account dot accounts dot add, and I'm going to simply add an account. So I'm going to get the account information from my config. Okay, so I'm going to simply say config. So this config that we imported from Brownie will enable us to have access to all the variables, all the information that is inside of this YAML file. So I'm going to say config, and then I'm going to go config, and in here I need to go into the wallets, which is this right here, wallets, this right here. I'm going to get access to the wallets. So wallet, after getting access to the wallet, I want now the private key that is associated with the wallet, right? So I'm going to go in here and get this private key that is associated with my wallet. So I'm going to go there, copy this, and simply paste this in here. So great, that's all I need to do. So I think I have an error here and I need to close this off. Yeah, so let me see, open this. Okay, I need to delete this right here. Yeah, so that's all I need to do. Config, get me the wallet, and then from the wallet get me the from key. So wallets, and then the from key, which is going to be the private key to our wallet, and it's going to return that specific network. So great. So once we have this done, I'm just going to go ahead and actually call get network here. So I'm going to get underscore get account So this is going to return to us the account we need to work with. So if you're on a development network, so if you just run Brownie, so let me just terminate Brownie run script, and then you just pay deploy, right, the scripts /deploy, and if you just run this without specifying the network, then it's going to go ahead and default to your Ganache local network. So in this condition we meet, if the actual network is active network is development, then it's going to get us the Ganache network. Else, if you have any network specified, then it's going to use that specific wallet address, okay, that is inside of our env file. Okay, so let's check if this run. Yeah, this runs successfully. Now let's try to run this again with our own network. So you can just say --- network, and then you can specify which network you want to run. So I'm going to run with the Rinkeby network. Okay, so Rinkeby network is one of the networks under the Ethereum blockchain. So you can see Rinkeby network here, which is under Infura, the place where we got our private key from. So I'm going to use that Rinkeby network. So I'm going to try to run it. So we got an error. It says that unexpected variable in storage. So Rinkeby URL Infura web3 URL ID. So I think I have an error. Okay guys, I think I made a very crucial error here. So one thing I forgot is that I made a very simple silly error. So this environment should be inside of our simple contracts here and not inside of the scripts folder. So let me just go ahead and fix all of that. So let me just bring this here, and I'm going to say move, and then I'm also going to bring this one also here, and I'm also going to say move. So make sure that we have all this inside of our simple contract, so we have all that in there. So it's not inside of the scripts folder, rather is inside of the root directory. So my bad for that. And if you get an error code, I forgot one thing to mention, you have to run source and then .env. Okay, so that will make sure that everything is fixed. So because when I ran an ls, I didn't see that folder there. So now let me just clear this and run an ls again. Now you can see we have that .env. So let's go ahead and try to run that command again. So Brownie run scripts deploy pi, and then the network is Rinkeby. Okay, so I'm going to go ahead and run that. So it's going to go ahead and deploy our smart contract on Rinkeby. So it's going to go ahead and actually do that. So you just have to wait a bit, and you can see all this information like the gas price, the gas limit, the nouns, and other information like that. These are just some technical words used in blockchain. I'm not going to go into depth about that. So nouns is a num that is used only once and stuff like that. I'm not going to go into depth about all the gas fees. But one thing you need to notice is that whenever you are going over setting up your wallet, they also tell you to include some fake money inside of your wallet. This one you need to include fake money inside of your wallet is because you need to pay some gas fees to use an actual testnet. So that's those fake money enables to use those testnets. So once we can see our contract has been deployed at this address, so let's copy this address. I'm just going to copy it. So copy this, and I'm going to go into my browser, open up a new window, and I'm simply going to go into you can even see I have the link shown right. You can go to rinkeby.etherscan.io. So if you go to this link etherscan.io, rinkeby.etherscan.io, so in here you can simply paste that contract, the address that you copied, and simply search for it. So this you can find your Rinkeby contracts right here. Okay, so sometimes it takes some time to show or this to show up, so you just have to wait a bit for this to show up. So we just have to wait a bit for this to show up, and if it does, it will show up here, and you can see that contract being deployed right here. So sometimes you need to take it takes some time, and you need to wait here to be able to see that contract right here. So yeah, that's how you can deploy it to a simple live testnet. Okay, so once we have that, let's go ahead and learn how to run different tests. So if you go into the test folder right here, this way we can go ahead and run different tests to make sure that our blockchain works as we expect it to. So let's go and see how we can run a test here. So I'm just going to go into my test folder. I'm just going to create a file here. I'm going to simply call this it's going to be test underscore simple underscore storage, okay, .py. So in here we can go ahead and actually run the test to test our application. The first I'm going to do to check, I'm going to test it if it creates the student, and then I'm going to retrieve a student, and I'm going to retrieve all the students. Okay, and then I'm going to check if it matches the data that I try to store on the blockchain. So I'm going to go from Brownie import simple storage, just like that. I also want to import accounts. I'm just going to be testing this on my local network. I'm not going to be using a test network. I'm going to use my local Ganache network for this. So I'm going to say dev, and I'm going to simply say test underscore creating underscore student, and this is going to be a function. So in this function, what I'm simply going to do in here, now, the first thing, when you're testing your application on Brownie, there are many steps that you need to follow. The first one, there are 3 main steps. The first one is arrange. The second one is act, and then the very last one is to assert. So assert. So let me get the spelling of assert right. So let's first go over arranging. So what does it mean to arrange? So this here, just do the basic setup and deploy the contract and all of that. So I'm going to say account is going to be from my accounts, and I'm going to get the very first account, which is going to be the Ganache-cli account. So once I have it, I'm going to create a simple underscore storage, and this is going to be the simple storage contract and deploy. And I'm going to pass in a dictionary here, and I'm going to say from which account you're deploying this from, and the account is going to be from our Ganache account. Okay, so once we have that, it's going to deploy this, and we're simply going to print let's say that deployed successfully. Yeah, so that's what I want to do, and this is a string, so my bad, make sure that the code keep this in double or single quote string. So it's going to deploy that. Yeah, and then you can do go ahead and try to create a student. So let's go inside of the action path. Let's try to create a student here, and this is going to be equals to simple storage dot create, and this function right here, and I'm getting this function from here. So I'm going to copy this function, go in here and paste this function right here. So I'm going to say create, and I'm going to simply pass in, what do we need to pass in to create an account? To create a new student, right? We need to pass in the name, the age, and then the faculty. So let's go and specify that. So I'm going to say Prince, and then the age is going to be a string. So let me just say that maybe I'm 89 years old, and then I'm doing computer science, just like that. So that's all we need, and this is going to be a transaction, and transaction on blockchains takes some time. As you can see, when we went to the Rinkeby part, it took some time, and so what we need to do, we need to wait for this in application. So I need to say wait, and pass in here, we just pass in 1, and it's going to wait for that contract to be that transaction to be successful. And if it's done, we just simply go ahead and print student created, just like that. And then after that, we need to do an assertion. For this time, I'm just going to say assert, and then just going to pass in through here. So just a simple assert statement. So great. So now let's go ahead and actually test this. So to test your program in Brownie, so what you simply have to do, let me just clear this. You have to say Brownie test, Brownie test. I think, let me just check the documentation right here, so that you don't waste any time. So let me just go back. So go back one more time, and then in here we need to actually say Brownie test, just like that. So let me just go into the terminal and simply say Brownie test, and then run this. So this is going to go ahead and run all our tests and make sure that our application works as expected. Since you have only one test, then only one item was collected, and it's going to go and the text that has successfully passed. So you can also do .s. I think that s is going to show the verbose and stuff like that. So let's just wait for this to be complete, and let's see. Yeah, so you can see the text has been passed. So you can see it has deployed, and then it has created that student, and then the test was passed. So great. So it works as we expect it to. You can also write many tests in here, and another test I want to write is try to retrieve the information from only one specific student. So I'm going to say dev, and then this is going to be test underscore retrieve underscore student. So what this is going to do, we're going to follow the same process. First of all, we need to have an act. So I'm going to copy this and simply paste it in here. After that, what we need to do is we need to act. Okay, so what we need to do is we need to assign the students. So I'm going to copy this part, copy it, and then simply paste it here. So the acting part, I'm going to simply create a student, and then I want to create 2 students in this case. So I'm going to copy this, and then simply paste it here again. I want to create 2 students, so let me just pass in here. Let me say this is Janet. Let's say Janet is maybe 19 years old, so let me change this to be 19, and then also doing computer science. Okay, or let's say he's doing business. So Janet is doing business. So we're going to wait for those transactions to be completed, and once it's completed, we can just print the students created. So let's just say students created, and then after that we need to now assert something. So we need to say create an assert statement. So I'm going to say student, and the student is going to be simple students student info, because I want the information of only one specific student. So this is going to return to me a tuple, and a tuple of tuples. So I want to get the very second element of the tuple, which will be this Janet data, right? So I'm just going to copy this, and I'm going to go ahead and I'm going to just print it out. I'm going to print out the student that we got. So student, and I'm going to go ahead and try to do assert. I'm going to make sure that the student that we got from the database is credentials, or the tuple matches the tuple that we use right here. And if that is done, then you can see that the text has passed. So let's go ahead and try to clear the terminal and run this test again. So it's going to collect 2 items because we have 2 different tests. So it's going to run the first test, which is going to create student. The second test is going to deploy the student. So you can see it has created a student called the student information, and it matches the one which is the second element of that list. So you can also go ahead, actually let me just copy this right here, copy this, and you can also print it out. So print, and then you're going to pass this in here. So if I just go ahead and try to run this one more time, so clear the terminal and run this. So you can see the first test has passed, and then you can see the second test, which is right here. We have it here. Now I don't want to get only the first student. I want to get all the students. So I'm just going to I can get students. Students, it is this function right here, and it's going to return to us a list of all those students. So I'm going to copy this and simply paste it here. Okay, so it's going to return to us a list of all the students. So since I created 2 students, I want to see if all those students were created. So I'm just going to run this again. So you can see the first test went through, and then the second test went through. So the second test, we have a tuple containing tuples, right? So the very second element, which is the first index, is Janet, and the Janet information is this one, and it matched this information when you did an assert. That's why we got the test pass through. So great. So now let's run another test to test getting information of only one specific student, or sorry, of a bunch of students. So we can go ahead and try to do that. So what you can simply do here, I'm just going to copy this right here. So I'm going to copy all of this. So I'm just keep a bit of code comment here. I'm going to call this one to be the asset part of it. So I'm going to go ahead and copy this again, copy this information again, and then try to paste it right here. So I'm going to go ahead and actually paste it right here. So it's going to be very similar to the one that we have here. So I'm just going to delete this part right here. So we're going to create an account, deploy, and then simply create 2 students, and then we print the student have been created. And then I want to simply get the students information. It's going to return to me a list of all the students, right? So I want to simply go ahead and store this in a variable called students, and the students is going to be this, right? So now that we have that information, so I'm going to simply create this to be students. So I'm going to check if the students, the very first element, is going to be equals to this one right here, because it's going to return to us a tuple of tuples. Now the tuple, I'm going to get the very first element, which is going to be this one right here, because this was the first student that we added to the blockchain. So I'm going to paste this right here, and if that information matches this, then the test should pass as well. So test retrieve students. Okay, so now let's go ahead and try to clear the terminal and run this again. So you can see we got an error here. It says that computer science to whale. So let me see how we can go ahead and solve that error. So let me try to place this to be index 1, and let me see if it will match this right here. So copy this, and I'm simply going to go ahead and paste it here. Copy this part here, copy it, and simply paste it here. And I'm going to run my network again. So you can see it has passed successfully, and the information has passed successfully. So now you can see that our test has been all our tests went through successfully. So yeah, that's all I wanted us to discuss in this tutorial. So you can also go back to the, before we just end this, let me go to the Rinkeby etherscan.io. So in here I want to go ahead and try to get the information, because last time we deployed we didn't actually see that being going through. So let's try again and deploy this. So clear the terminal, and I'm going to simply run Brownie, and then run scripts, and then I want to run the deployment script. So run this, So let me just exit it because I don't want to use the local Ganache network. So I'm saying hyphen network, and the network is going to be the Rinkeby network. So Rinkeby network, just like that, and run this again. So this will deploy this contract to Rinkeby, and you can get the address to the contract and simply verify if it has been deployed. So you can also write the code to verify this, but we'll cover that maybe in a future video. So let's go ahead and it has been deployed at this contract. So let me just go ahead and get all this, copy this, go into the Rinkeby and simply paste it in here and then search for it. So sometimes it can take a bit of time to show this information, so sometimes you have to wait a bit to make sure that this information is complete. So now I've been refreshing the page, and you can see that the transaction went through, and you can click on this and then you can see that the contract right. So this is a contract and it has been deployed successfully, and yeah, that's how you can deploy to an actual testnet and how to actually test it on your local network. So this is how to build a simple blockchain using Python. In case you guys want to learn anything more about blockchains, leave a comment in the comment section below. I'll do my best to get back to you. And be careful when working with your private keys, in case your wallet contains an actual money like Ethereum or Bitcoin. Avoid sharing this your details with anyone. Okay, so this how this all for this tutorial, and you can find the link to this tutorial or on my GitHub page. The link is in the description below. So if you enjoyed this tutorial so far, give it a thumbs up and subscribe to my YouTube channel for more videos like this. Thanks for watching, and see you in the next one. Keep safe.